All right, hi there to those people watching the recording. Um, here's a little help on WebWork 12.2.2 that we talked about for a moment. I did want to talk about some business before we get started here. So I graded up your labs and collaborative proofs and some of your graded proofs. I have some more of those to do. I'll try to get to those as soon as possible. If you do want to redo any of those things, you can and turn them in late. The deadline for late work is going to be Wednesday of next week. So a week from tonight will be sort of the final deadline for all late work. Um, and so I'll try to get those grades in either tonight or tomorrow so that you have, a good solid week to be able to, fix things that you want to improve your grade on, and also to study for the final exam. So speaking of which, your practice proofs for this week, collaborative proofs for this week, is a practice final. So you can work on that. There won't be a lab this week because I just want you guys to focus on the final exam. Your final exam is going to be, um, let's see here, where's that? Make sure I got the dates right. I was going to give it to you Sunday to Tuesday. Oh, I don't have it on here. Okay. So, so I believe we decided we were going to do a timed final, just like the midterm. Isn't that right? Yeah. Okay. Yeah, I thought so too. So yeah, so the final exam, I need to actually rebuild it. It's in a Dropbox right now, but I have to put it into a quiz. So I'll give you from Saturday night at midnight. So you have all day Sunday, Monday, and Tuesday. It'll be due Tuesday night. So I'll give you, 3 days, just like the midterm. And it'll be a similar sort of thing. 5 problems. You grade your top 4 out of 5. That whole shtick. I will be in lecture in the Zoom room on Monday from 1 to 4 if you'd like to take your exam at that time so that you have the ability to ask me real-time questions, right? If there's something that's confusing on the exam or there's a typo or, whatever, I'll be around during that time on Monday for y'all to come hang out and take your exam at that time. If you want to take it at a different time, if you're, watching the recording right now, you can't make this time, no big deal. You just won't be able to ask me real-time questions. Yeah, so Monday during class is our last meeting, but we're not gonna, I'm not gonna do lecture. I'm just gonna hang out and answer questions. So I'll be there to answer questions for you if you need, but we're not gonna do a formal lecture or anything like that. Yeah. Okay. So that's the sort of the business. Any other questions about the end of term here? We're getting right down to the end. So sorry, this is our last lecture today. So if anyone has any burning questions for me, now's the time. I'll let you think about it. Okay, cool. So in that case, let's jump back into the material for chapter 12. Today I wanted to talk about a few more examples of finite state automata, and then we'll get in and their relationship to regular expressions. Then we'll get into non-deterministic finite automata. And finally, we're going to end with a proof that shows that every finite automaton correlates to a regular expression and vice versa, right? So it turns out that the class, or the set, I should say, of regular expressions is exactly equivalent to the class of finite automata, and you can sort of translate back and forth between those two different ways of expressing languages, right? So that's sort of where we're headed today. But I'd like to start out with just a few more examples of these finite automata, right? So let's begin with an FSA, a finite state automata. That's one of these guys, right? The little arrow diagrams here, directed graph, right? On the alphabet 0, 1, that accepts all binary numbers divisible by 3? Okay, so first of all, let's do a couple examples here. So can someone give me a binary number that's divisible by 3? One, right? 1 equals 3, right? Which obviously is divisible by 3. Okay, let's do another one. Okay, 1. Okay, so that's equal to 15, which of course mod 3 is also equal to 0. Okay, other ideas? Okay, 101. 101, that's, well, that's 5, right? So that's 4, no 2's and a 1. So 5 mod 3 is 2, so that's not divisible by 3. So, but that's okay. This one's not in the language, but that's fine. You meant what David said. You meant 9, right? So here's 9, which of course is divisible by 3. It's okay to have some examples that are not in the language as well. That'll help with our understanding, right? And David, there's 12, 1100. Okay, so we've got a bunch of examples here and one non-example. Fine. So what we need to think about with our finite state automaton is a little bit longer kind of string, right? So for example, if I had the string 1101001 blah, 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 and it keeps going, right? All the way down to, we have a 0, 1 at the end. Well, what's going to happen with this string? Well, this is some really long, some big binary number. As we're reading these bits, what we're going to do is move around in our FSA. So maybe we'll stay in the same state, maybe we'll move to a different state, right? And really the question that we need to start with here is how many states do we need in our FSA, right? How many different situations could our string be in regarding divisibility by 3? Okay, 3 of them. Okay, and why would it be 3, David? What would those states represent? Remainders, okay. So we'll have the mod 0 state, or let me say mod equals 0. Or how about mod 3 equals 0, right? So of that state, we'll have mod 3 equals 1. That'll be another state. And then finally, mod 3 equals 2. Okay, and what's going to be our except state here? Yep, mod 3 equals 0. That'll be the one that is actually divisible by 3. So that'll be our except state, right? What's going to be our start state? Again, 0, right? Because if we start off at the beginning and we just have a 0, right, then we want to, that'll be a check, right? Because 0, if we have 0, that equals 0, right? Mod 3 equals 0. So we'll start off here, right? Okay, well, now we can start thinking about the transitions, right? So if I have some zeros, right? Or we'll just put it this way. If I have an empty string, there's nothing in it, and I just throw a single 0 on the front, what state am I going to be in? In other words, the 0 from this state goes where? The 0 arrow. To itself, okay. What if we have a bunch of zeros, right? 0, 0, 0, 0. So we stayed in this state for a while, and then we read a 1, right? So we're in this state, reading a bunch of zeros, and then we see a 1. Where do we go from there? right? Mod 3 equals 1. And that's actually true no matter what. What if I had 12, right? 1100 equals 12, right? And then I throw a 1 at the end. So I read another one. So I didn't read all zeros to get here, but I am in the state where I have mod 3 equals 0, which certainly should be true for the number 12, right? Because it's, mod 3 equals 0. So I should be in there. If I read another 1 afterwards, I'll end up with this string with a 1 at the end. And I should end up in this state, right? Well, what binary number is this? When we add digits to our string, we add them to the right side, right? Because we start at the left and we read bits from left to right. Yep, so, okay, you got it. Okay, so what binary number is this? Okay, 25, good. Is 25 mod 3 equal to 1? Is that true? Yes, right? Because 3 times 6, or pardon me, 3 times 8 equals 24, and then plus 1 equals 25. So even if I have 12, 1, 1, 0, 0, and I tack another 1 on the right-hand side, that does bring me from the mod 3 equals 0 state to the mod 3 equals 1 state. And there's good reason for that. If I take this number, 1, 1, 0, 0, and I throw a 1 on the end, what's that doing to the decimal numbers arithmetically? How do I go from 12 over to 25? Like, what's happening to this in terms of arithmetic when I concatenate that 1 on the end of the string? Good. Times 2 plus 1, right? And so what's happening is, well, I'm taking something that's divisible by 3 and multiplying that by 2. That's to scooch the number over to make a new spot, right? Anytime I scooch over the bits, that's going to multiply that number by 2. And then I put a 1 at that last spot, right? Which means, okay, well, if I have something divisible by 3 already, multiply that by 2, it's still divisible by 3, right? Just like in this case, it's 24. And then I add a 1 onto that, which of course changes it to mod 1, right? And that's exactly right, Sean. Just adding another 0 to the right-hand side is just a number times 2, right? So if I start out with a number divisible by 3, and I multiply it by 2, well, it's still divisible by 3, right? What about this? What if I take a number mod 3 equals 1, and then I multiply it by 2, right? So I have some number, 3k plus 1, right? Right, is going to be my number because it's mod 3 equals 1. So something times 3 plus 1. I take that whole thing and multiply that by 2. In other words, the 0 arrow coming from this state is just multiplying the whole thing by 2 because it scooches everything down, right? So for example, 1, 1, 0, 0, 1, and then I put a 0 at the end, right? Scooches everything down by 1, which in effect just multiplies everything by 2, right? So there's some number, mod 3 equals 1, multiply by 2, and what do I get? 6k plus 2. So mod 3 equals 2. So the 0 coming out of here goes into the mod 3 equals 2 state. People see why? You got the plus 1 and multiply, and I get the plus 2 now. Let me pause there for a minute so people have questions. No, we're not adding to the left side because we're reading these bit strings in order from left to right. So each additional bit is going to come on the right-hand side. We could have said, hey, we're going to read it from right to left, but that's going to give me a different sort of formula in terms of it's going to end up with a different FSA, right? It's going to come out with a different little arrow diagram if we read things the other direction, right? Yeah. Okay. So Sean, you're saying 2 times the 3k plus 1 goes to 3k plus 3, right? So if I have a plus 1 on here, right? that equals 3k plus 3, which means the 1 coming out of this state goes back to the 0 state. Very nice. Awesome. Okay. So now we've got 4 out of my 6 arrows, right? All that I have left are the 2 arrows coming out of this final state, right? So what if I have 3k plus 2 and I multiply that by 2? What am I going to get? Plus 1, right? Because it'll be 6k plus 4, which equals 6k plus 3 plus 1, right? So reading a 0 from this state goes back to my mod 1 state, or mod 3 equals 1 state, okay? And what about reading, oh, I'm sorry, that was a 0. Pardon. Oh, wait, what did I do? No, I'm sorry. Yeah, that was supposed to be a 0 here. Sorry, typo. Okay, what about reading a 1 from this guy? Stay at 2. Okay, so if I read a 1, what am I going to have? Well, I'm going to have 3k plus 2, or 2 times 3k plus 2 quantity plus 1, which is going to be 6k plus 5, right? Which is 6k plus 3 plus 2. So I'm going to be staying in that plus 2 state. So there's my 1. And this is my finite state automata that can read bit strings and decide whether or not they're divisible by 3. So let's do some examples. So I'll start at the top, 1, 1, right? So 1, 1 takes me back to the start state. How about 1, 1, 1, 1? I'll go 1, 1, 1, 1, and that's accepted. This should not be accepted, right? 1, 0, 1 leaves me here, which is a fail. Okay, so that's correct. About 1, 0, 0, 1. Okay, so I have 1, 0, 0, 1. That takes me back, and that's accepted. How about 1, 1, 0, 0? That one works. How about 25? That should land me right here, right? So if I go 1, 1, 0, 0, 1, yep, that lands me at a mod 3 equals 1. And lastly, how about this guy? That's 50, which should be mod 2, right? So I should have 1, 1, 0, 0, 1, 0. Yep, that lands me at mod 2, or mod 3 equals 2. Right? So it looks like my machine is working. What do you guys think? Questions? Satisfying. Yeah, isn't that cute? Right? Can build these little machines that'll do little jobs for you, right? So let's do a couple more. Yeah, this is my favorite topic in the course by far. It's to me, this is just really fun. Not so annoying like a lot of the other stuff we do, right? Okay, so let's talk about even length strings. And I think we may have done this one last time, but that's fine. So let's do strings of even length on sigma, again, equals the alphabet 0, 1. Okay, so first of all, let's do a regular expression for this. So we want a regular expression, right? So we want to list out strings with either the or the star or concatenation, right? and we want every possible even length string. Okay, you're close, Sean. So you could have either a 1, 0 or a 0, 1 as many times as you want, but you also need the 1, 1 or the 0, 0 as well. Very nice. And that's the right answer. So we could have 0, 0 or 0, 1 or 1, 0 or 1, 1 as many times as you want, right? Cool. Another way of writing this, just to be clear, is I could say 0 or 1 followed by 0 or 1 quantity star. And that's saying the same thing. Because if I have a 0 or a 1 concatenated with a 0 or a 1, there's 2 options here times 2 options here gives me the 4 options there, right? See how the combinatorics comes into play here? Any questions about that? Okay, cool. So now let's try to make an FSA that will recognize this. Right? So how many states am I going to need for this thing? Yeah, 2, even and odd. And which state am I going to start in? Okay, even for empty, right? So this will be even where I start. Here's odd. Which one will be my accept state? Even will be the accepting state, right? That's what I'm looking for, even length strings. Okay, if I'm in my even state and I read a bit, where do I go? Do I stay even or do I switch over to odd? Go to odd for either 0 or 1. Yeah, it doesn't matter what I read. No matter what I read, I'm going to have odd length now. So I'll say 0 or 1, take me over to the odd length state. If I'm in an odd length state and I read another bit for my string, where do I go then? Either one sends you back. Perfect. So I got a 0 or a 1 sending me back. And that's my answer, right? So I got 2 different ways of writing the regular expression. There's my FSA. And so you can see there are these 2 different ways of expressing the idea of the language of even length strings. What do you guys think? Questions? Where we go from, yeah, so we're going to do that in just a minute. Yeah, definitely. That's going to be sort of the latter part today. We're going to go FSA to regex, then also regex to FSA. We're going to go both directions. Yeah. Okay. So let's see, what do I want to do next here? Strings, I did that one. Okay, did we do this one last week? The one where the string doesn't have 2 1s in it? Have we done that one yet? We did. Okay, yeah, I thought we did. Okay, so let's move on to the next one. Sorry, one moment. Okay, so this one actually, we're going to start with the regular expression. Okay, so here's a regular expression. So we're actually going to do the reverse of what you said, David. We'll go the other way. So here's my regular expression: 0 star or 0 star 1, 0 star 1, 0 star quantity star. Okay. So there's my regular expression. Can you describe in English what this regular expression is going to accept. Okay, even ones or no ones, and let me just shorten that, Nathan. Well, and David, let me say it could be more than 2 ones because this guy is start, so I could have 4 ones or 6 ones, or no ones. That's this guy, right? But that's still an even number of ones because if you have 0 is an even number, right? So if I don't have any ones in my string, then that still counts as an even number of ones, right? So I'll say in English, this is going to be an even number of ones in the string. What do you guys think? Is there questions there? Okay, no questions. So if I'll let you keep thinking here, and in the meantime, see if we can do the FSA. So what's that going to look like? It's not going to be too different from my last one, right? Yep, even and odd states. Okay, which state is the accept state and which state is the start state? So let's do the accept state first. So will the even or the odd be the accept state? Even is accept state and start state. Very good, right? Because we start off with no ones in the string, which means an even number of them. So that's a start. And that's also what we're looking for, is an even number of ones. So it's also the accept state. So here's even, and here's odd, which is rejecting. So just a single circle on that one. Okay, if you have an even number of ones and we read a 0, where do we go? Let's do the 0 arrow on the even state. Loop, good. So if we have an even number of ones and we read a 0, we still have an even number of ones. Okay, the 1 from the even state, where does that go? Over to odd. Okay, how about from odd, we read a 0, where do we go? Loop. And odd reading a 1, back to even. Very nice. Okay, so what do you guys think? We started with a regex, we got what it means in English, and then from its English meaning, we were able to create the corresponding automaton. Questions? Yeah, it looks easy that way. Okay, so let's do a harder one, right? Okay. Okay, so in this language, I'm going to have my alphabet is 0, 1, or 2. So now I'm going to be working with trinary numbers instead of binary numbers, right? So base 3 numbers. And I want the numbers divisible by 5, right? Is there some nice set of rules for doing these from regex to automata, or is it always thinking it out? There is a nice set of rules. Well, there's a set of rules. It's not that nice, right? So there is an algorithm where you can go from one to the other. That's actually how we're going to prove that they're the same thing, is we're going to give algorithms to go from one description to the other and a different algorithm to go back, right? But those sets of rules aren't going to be easy. They're going to be kind of gross. And so thinking about it is kind of nicer in the sense that you'll get a prettier machine that pops out if you think it through than if you follow the rules. The machine you get that pops out, since the rules are gross, the machine you get is kind of, the FSA you get will be kind of gross and gnarly looking. So, it's kind of pros and cons. Does that make sense, Sean? Yeah, cool. Okay, so if I have this as my input alphabet, 0, 1, or 2, I have a trinary number. I want all of the trinary numbers that are divisible by 5. How many states am I going to have in my machine? 5 states, right? So I'll have mod 0, mod 1, maybe I'll go up like this, mod 1, mod 2, mod 3, and mod 4. Okay, so those are my states. What's my except states going to be? Just mod 0. Okay, so that's my except state. And what's my start state going to be? Yeah, also mod 0. Very good. Because I'm going to start off, if I have a 0, right, just the number 0, right? 0 mod 5 equals 0. Check. Right? And that's where I'm going to start off, just with a 0. Okay. So what if I have a 0 and I read a 0? So I just said I'm going to stay here. Right? Because if I have the string 0, 0 mod 5, well, that still works. Right? Or if I have some number that's already divisible by 5 and I tack another 0 on the end, right? Well, what is that doing? Well, that's multiplying my number by 3. And of course, anytime you multiply by another number, it's still divisible by 5, right? So if I start out with, 25 and I multiply by 3, I get 75. Well, still divisible by 5, right? Okay, what if I'm in the 0 state and I read a 1? Where do I go with that? I go to 1. What if I'm in the 0 state and I read a 2? 2. Okay, nice. There's a 2. Okay. And now am I done with my 0 state? Am I finished with this guy? Yeah. And how do you know that? Yeah, we used all of the input alphabet, right? So the way that you know if you're done, if the number of arrows coming out of your state is equal to the number of symbols in your input alphabet, right? Because what you need to do is you need to cover every possibility. When you're in a state, you might read a 0, or you might read a 1, or you might read a 2, and those are all the things you might read. So you cover every possibility, and that completes all of the possible outcomes for that state. Right? So how many arrows am I going to have in here total in my FSA? 15. Yep, very nice. Okay, so let's fill in the rest of it. So if we're in mod 1, reading is 0, what happens? We go to mod 3, right? Because reading is 0, what that means is multiplying a number by 3, right? And if we have that extra 1 dangling off, multiply by 3, well, reading a 0 is going to take us down there. Okay, what about mod 1 reading a 1? Yep, because we'll multiply by 3 and then add a 1 to it. Okay, what about reading a 2? Yep, back to 0. Good. Very nice. Okay, and now the state mod 1 is complete. I did my 3 arrows out of that. Okay, let's do mod 2. So what happens there? Sorry about that. So mod 2, reading is 0. What happens? I go to mod 1. Okay, so mod 2 means my 2 gets multiplied by 3 because everything shifts over by one trinary place, right? And so my plus 2 gets multiplied by 3, which gives me a plus 6. And I'm wondering about divisibility by 5, right? So 6 divided mod 5 leaves you with a remainder of 1. Yep, because we're divisible by 5. Yep, exactly. So the 2 reading a 0 takes me up here. Okay, what about mod 2 reading a 1? Loop, very good. Right, because reading a 1, I multiply by 3. 3 times 2 gives me 6. Plus 1 is 7. Mod 5 is 2. Okay, good. And how about reading a 2? Mod 3, very good. Okay, so that's where the 2 takes me. Okay, so 2 states left. Let's do the mod 3, reading a 0. What happens there? Zero goes to mod 4. 3 times 3 is 9. Mod 5 is 4. Okay. Reading a 1. Over to 0. Okay. Let me go around the outside here. Oop. Reading a 1. Right? Okay. And then? Reading a 2 out of the mod 3 state. Yep, reading a 2 takes me up to 1. So why don't I put that in here? Right, and that's reading a 2. Okay, good. Last state, mod 4, reading a 0. Where do I go? Yep, to the 2 state. Very good. Right, mod 4, reading 0. 4 times 3 is 12. 12 mod 5 is 2. I'm going to come up here. That's reading a 0. Okay. How about reading a 1 on my mod 4? So it'd be 12 plus 1 is 13. Mod 5 is 3. Very good. So here's my 1 arrow. Last arrow, mod 2. Where's that going to go? Loop. Beautiful. Okay, there's my finite state automaton, all done. Okay, let's test it out. Okay, so can someone give me a trinary number that's divisible by 5? Let's try it. Let's do this. Let's do a conversion. Let's do the number 25 in trinary, right? So 25 is equal to what? Well, okay, so let's talk about my place values. You got 21012. Let's talk place values. So my rightmost place value will be the what's place. That was just a number divisible by 5. Yeah, let's do 25 in particular. So to convert to trinary, right, what's the rightmost place value? Okay, 1s, 3s, 9s. Okay, so I got the 1s place, the 3s place, and the 9s place. So this is going to be a 3 trit number. right? These little, each little, it's not a digit because dig means 10, right? So, but this will be a 3-tridget number, okay? So for 25, how many 9s do we have? How many 9s can fit inside of, yep, 2 9s can fit inside of 25. That gives us 18. 18 minus 25 is 7 remaining. So how many 3s do I fit? 2 of them, right? And then a single 1, right? So 18 plus 6 plus 1 gives us 25, right? So if I go 2, 2, 1, right? On this diagram, starting here, I should get back to my starting place, right? So if I go 2, that goes here, 2 goes right across, another 2 goes down here, and then a 1 takes me around all the way back up. So here's the path that I took on 2, 2, 1, which does in fact take me back to my starting point to a number that's divisible by 5. Okay, let's try another number that's not divisible by 5. Or actually, David, why don't we do the other way real quick before I do that? I'll do yours. So if I do 210012, okay, 21012, what number is that? Well, here's the 1s, 3s, 9s, 27s, and 81st place, right? Oh, yours doesn't work. Okay, so let's fix it, right? So you did 2, 1, 0, and then 1, 2. So, but you wanted to get back. So maybe I should do 1, 1 instead, right? And that'll get me back. 2, 1, 0, 1, 1, right? So it'll be 2, 1. Oh, oops, sorry, I went the wrong way. 0, 1, 1, 1. Okay, let's do, crap, I screwed this up. Okay. 0, 1. How about 0, 2, 0? Yeah, let's do this. That one I think is divisible by 5, right? 2, 1, 0, 2, 0. Let's try that. 2, 1, 0, 2, 0. Okay, that one is divisible by 5, or it should be. So let's compute it, right? 2 times 81 plus 1 times 27 plus 3 times 2. So we got 6 plus 27 is 33. 81 times 2 is 162. 162 plus 33 gives you 195, right? Which is divisible by 5. So that one appears to have worked. What do you guys think? Happy? So sorry, I had to edit yours a little bit, David. Now, David, let's actually do yours, right? 21012 is not divisible by 3. What number is it? All of you guys answer this one. $193. Yeah, because this one is a 6 and this one's a 5, right? 194. All right, so 194 is not divisible by 5, so we shouldn't end up at the except state if we run through these digits. So let's do it. We've got 2, 1, 0, 1, 2, and we got the mod 4, just as we were supposed to. Very nice, right? Does everyone believe me that this machine can calculate divisibility by 5? Right? Translating to regex is going to be real gross. So that's actually where we're heading next, right? But I just want to do, quite a few of these guys. Yeah, translating this to regex is it's not fun. We're not going to do that. It would take way too long. It's too complicated. So, okay, other questions? Okay, cool. So let's take a short break, and then we'll come back and talk about translation and how to go from a regular expression to FSA and back, right? All right, we'll take 5. I'll see you soon. All right, so at this point, we're going to start talking about transforming a regular expression into a FSA or back. And we're going to run into some trouble. So let me give you a telling example. Okay, so let's talk about strings that end in 0, 0. Okay, so first of all, let's give a regular expression for this. Okay, perfect. So we've got 0 or 1 star, right? So anything you want with a 0, 0 at the end, right? Now let's see if we can come up with an FSA for this. Now, what's our approach going to be here? So let's just discuss in English for a minute. Like, what kind of states are we going to have? What are the states going to represent? You know, what's our starting state? Stuff like that. Ideas? Okay, so let me help. 0, 1, and second 0. Okay, so that was going to be what I said to help. So I'm with you. So we can have 3 states, right? A start state, which is a 0, right? This is not an accept state. This is just like the state where we haven't read anything yet. We can go to the state where we read a single 0. Then from there, we can go to a state where we've read 2 zeros, which is the accept state. Right? Is everyone with me so far? So this will accept the string 0, 0. Right? 0, 0 is accepted. Okay. Well, what are we going to add now? Like, now, what else is going to happen? So I've done my 0 coming out of here, my 0 coming out of here, right? What about my 0 coming out of here? Let's get all the zeros in. Right? So what is 0 coming out of here going to do? That's going to loop, right? Okay. How about 1 coming out of here? What's that going to do? Loop, okay. So this guy is a 1 on a loop, and 1 coming out of here? That goes back to 0, right? Because then I don't have a 0, 0 at the end. Very nice. Okay. Is this FSA correct? I mean, it has to, you know, this is what we had to do. That we didn't have any options when we were making this thing, right? So I hope it's correct, but is it? Oh, I'm sorry. We still need to assign. Well, so we did the one arrow for one. I'm sorry. We did miss this one though. So the one for one, that one's already there, but we still need the one for the two state. I'm sorry, I forgot that one. So if we're reading a one in the two state, where are we gonna put that? Should send you back to the start. Very good. Sorry, I forgot that one. Okay, now is it correct? It's better, right? I agree with you there. And what do you guys think? Is it right? Is it wrong? Does it accept some strings that it shouldn't? Does it miss some strings that it should accept? Does anyone see any problems with it? Perfect for you. Okay, so I think this is right, and because no matter what we read, no matter what, when we see a one, we come back to no zeros at the end. From there, if we ever get a single zero, we'll have, okay, there's 1 0 at the end. If we see another one, well, that gets rid of it. If we see another zero, that's 2 zeros at the end, and zero leaves us at least 2 zeros at the end following this loop. The problem that I'm seeing with this is that it doesn't correspond very well to the regular expression. Like we started off with this 0 0 business, and that's nice, right? Because we have to have that 0 0 at the end. But what I would really like is to be able to have anything happen at the beginning, and as long as I have 0 0 at the end, we're good, right? So here's really what I would like to do. I would like to have my start state with a loop on it where I can have as many zeros and ones as I want, right? Or I can read a 0 going into my 1 state and another 0 going into my 2 state, which is of course my accept state as well. That's really what I want, right? You see the correlation between these is so much nicer than the correlation between these, right? Here, this whole chunk of the regular expression is just my first state, my start state, right? Can loop a 0 or a 1 as many times as I want. Then I read another 0 to get me into the 1, another 0 to get me into the 2. What's problematic about this FSA though? What rules are we breaking here? Yeah, we have 2 0 arrows at the start, right? That's one of the problems. And David, you said the other problem, we don't have any 1 arrows coming out of 1 or 2, right? So we don't have a number of outgoing arrows from each state that's equal to the, the contents of our input alphabet, which I should have written down, right? So in this case, how can we determine the idea of acceptance, right? Because in order to accept, well, we could put in a 0 0, and that'll get us to accept. Or we could go 0 0 and just loop on this 0, which means we don't accept, right? So how should we define acceptance for this new kind of machine where we have, some sort of a goofy arrangement of arrows, right? That's not we have some choices for what we can do, right? So what would acceptance mean in this case?
Why not make a 0, 0 arrow? Oh, well, I'm still going to stick with the requirement that each arrow is only reading a single character from my bit string, right? So this arrow can't read like multiple things. It has multiple options for which direction it can go, but either way, no matter which option it chooses, it's still only reading one symbol at a time. This is just 1, 0 it's reading. And this is just 1, 0 that it's reading. It can choose which way to go, but it's still only reading that single symbol at a time. Does that make sense, David? So I am still obeying that rule, where each arrow is only dealing with a single symbol from my string. No, it's not too fundamental to break. We just haven't broken it yet, and we're going to. So that's why I wanted to clarify that, because we are going to break that rule. Yeah, but not yet. Okay, so let me ask my question one more time. Okay, if I could have 0, 0 get me to the accept state, or 0, 0 gets me to a non-accept state, right? Or let me do it this way: 0, 0 gets me to this non-accept state, right? I have different places I could end up depending on which options I choose for which arrows to follow with my 0 that I'm reading. So in what way then can I define acceptance if I do want that string 0, 0 to be accepted? Define it as choose to follow arrows to the accept state. Okay, you're on the right track, Sean, right? So I think what you're getting at is it's possible to get from the start state to the accept state, right? If you make the right choices. Is that what you're getting at, Sean? Sure, okay. So let me rephrase that a bit more formally. There exists a sequence of moves that will get you from the start state to the accept state. Doesn't have to be every sequence of moves, but there's at least one, right? So there exists, let me call it this way, there exists a path from start to accept. And that's our new definition, right, of acceptance. Okay, so what's our new definition of rejection? Well, there does not exist a path from start to accept. Okay, so let's see if we can work with that definition for a minute, right? So we'll do a couple of different strings here. Let's say 10100. Okay, should that string be accepted? Yes, it should, because it ends in 00, 0. Does there exist a path from the start to the accept state? I'll label this the 0 state again. There is. Okay. What is the list of states to get us there? So we're going to have, 5 states, one for each of these, one for each of these symbols, right? 0, 0, 0, 1, 2, right? So I go, and that corresponds to 1, I take the loop, 0, here, I take the loop, 1, I take the loop, this 0, I go across, and this 0, I go across, right? So that path does exist. Let's do one that doesn't exist, right? Let's try 11010, right? So this is a check. So again, we're going to have a 5 symbol string here. Is there a way to get from start to accept on this guy? Well, I would have to go 1 on the loop, 1 on the loop, 0. If I take this 0, then when I do a 1, there's nowhere to go. So if the rules here is if there's nowhere to go, I'm dead, right? Then it's an automatic fail if there's no arrow to follow that corresponds to this symbol. So that won't work, which means this 0 has to, again, loop me, which means the 1 has to loop me. And that last 0 can get me here, but I still can't quite make it over to the 2, right? So I almost got it. If I was to have another 0 on the end, right, then I could get there. But as it stands, there's no possible way to follow these arrows and get from start to accept on this string. Does everyone see that? Questions? We can make a fail state. And here's how we could do that. We could say, hey, well, anything that's not from these guys that's not defined goes to fail. So here's our fail state, okay? And we could put, this is a 1 coming off of here. This is a 1 or a 0 coming off of here. And of course, once we get to fail, we'll loop, right, and be trapped there. So it'll look kind of like this. Here's our fail situation, right? We can put that there, and that's fine, right? Here's our trap, right? Right, we can put that there, but also it's just kind of implied by the structure, right? If we just make a new rule that, hey, if there's no arrow with the number that you're reading, automatic rejection, right? Automatic fail. You can draw all this stuff in, but you don't really have to, right? Because if you're reading a 1 from here, you just say, oh, fail. Or if you have a 0, 0, and then you read something new, it's like, oh, well, I fell off the edge. It's sort of like falling off the edge of a flat earth, right? Like, well, I failed, right? I fell off the table, right? People happy with that? Does that make sense? So you either could put all this stuff or not. It's up to you. It's a little bit redundant, but you could put it if you want. Okay. So let me tell you what one of these things is called. Okay. So up here, every choice that you make is totally determined by your automaton. So another name for this, actually the more common name, is called a deterministic finite automaton, or DFA. This one is called a non-deterministic finite automata, or NFA. Because it's not determined in advance which way you have to go, you get to choose, right? And it turns out that if you use an NFA instead of a DFA, or what your book calls an FSA, right, then it's way easier to translate regular expressions, right? I mean, if I forget about this trap, right, you can see super easily the correspondence between the regular expression and the NFA, right? Maybe we should do another example, right? So let's let me pause for a moment. Assuming that I get rid of this trap and we don't look at it, are people seeing the correspondence here between the regular expression and the NFA? Had sort of how straightforward it is to translate, whereas the FSA we had to do a lot of thinking, right? This is very non-algorithmic. We had to be clever about where the ones take you back to the start and all this stuff, whereas this one you just throw down a state for each symbol, right? The stars have loops on it, and then you move through the states at sort of as you go, right? Are people happy with that? Any questions there? Okay, so let's try another example. This time, I'm going to start with a regular expression. Okay, so I've got 1 star, 0, 0, 1 star, quantity star. Okay, we won't worry about an English description for this one. It's not really a good description, right? So don't worry about the English description. Let's just go right into the FSA, right? Okay. So how many states do you think we're going to want here? How should I begin designing my FSA for this thing? 4. Okay. So give me some English, David. What's your thinking on that? What are states going to represent? How's the thing going to work? Okay, first state, a loop with a bunch of stuff. A bridge with 0, 0, 1. Okay, so we want a bridge with 0, 0, 1 from my start state to my accept state. Is that right? So should I start off with that? Yeah, okay, cool. So I'll have my start state, a 0, and then a 0. And now, do I want to go to a fourth state with the 1? Or should I do something else? I want to loop. Very good, because we got a 1 star on here, right? So I want to loop that 1 on the last one, and this is going to be my accept state, right? So if I do, 0, 0, 1, well, that's going to work for me. If I do 0, 0, 1, 1, like this, well, that's going to work for me. What am I going to do about my 1 star at the beginning? How's that going to be incorporated? Loop at 0. So this loop at the start state, is that right, Nathan? Yep, okay. So I've got a loop here with a 1 on it. Okay, so now I've got my 0 and 1. Remember, I have to have every arrow. This is my FSA, so I have to have every possibility covered. There's no choices involved, right? So I got a 1 and a 0 on the first one. I got a 0 on the second one, and only a 1 on the third one. So if I have, let's do this. Let's do the third one, right? If I have a 0, 0, 1, and I'm reading a 0 out of this state, where do I go? Back to which one? Let me label these states A, B, and C. Let me make this a little bit more clear. So here's A, B, and C, right? Not back to A, you're close though. If we have some junk and we're reading a 1, yeah, we go back to B, right? Oops, sorry, pardon me, reading a 0. Oops. Right? Because then if we have some stuff we're accepting, and then we have another 0, 0, 1, right? That's going to be our accepting string, right? 0, 0, 1. That's kind of our little trick there. Does that make sense why we go back to B? Yep. Cool. Okay, so then let's talk about what happens if we're in state B and we're reading a 1, right? Is C unnecessary? Could we just have B to A for 0? Well, no, because we need to count up that there's exactly 2 zeros here, right? If we just had 0 like as a loop on the A, right? Oh, I see what you're saying. Yeah, maybe we could do 2 states where we have 1 loop on both and then a 0, 0 back and forth. Is that what you're saying? Yes. Okay. Yeah, actually, that's kind of cute. I like that. Let me do FSA2. Okay, this one, I think we can get away with just 2 states. Let's see if it works. So now my starting state is going to be an accept state with a loop of 1s on it. I'm going to take a 0 across to a rejecting state and then a 0 back, right? So I can do as many 1s as I want, or I can do 0, 0, and then as many 1s as I want. What if I read a 1 from this state here? So I read a 0 and then a 1. What happens? Yeah, rejecting trap, right? So a 1 is going to go over here into a trap, which of course has a 0 or 1 on there, right? Similar thing is going to happen here if I read a 1. But if I read a single 0 and then a 1, that's also going to go into a rejecting trap, right? Does that make sense? I'm never allowed to have 0, 1 inside this string, right? One more little addition. This start state needs to be accepting, right? Because I could have an empty string that, you know, I could have an empty string, end of story, that gets accepted, right? So I have to start out with an accepting state. Pardon me again. All right. So there's two different FSAs that we made, a 4-stater and a 3-stater. Fine. Let's try to make the NFA, right? Okay. So for my NFA, in my start state, is my start state going to be accepting? Can I just do nothing and be accepted? So for my regular expression, yep, yes, right? So this will be an accept state. Okay. What if I read a 1 from here? And I want to make it possible to read a 1 and still be accepted. So what should I do? Okay, we want a loop, good. So there's a 1 on there. Okay. What happens if I read a 0? New state, okay, reading a 0, go to a new state. Okay. Then what? From this new state, I have to make it possible to accept, right? So what do I need to do after reading 1, 0? So I've looped as many times as I want, read a 0. I could have 0 return to the first state. That's true. And that's going to land me in FSA 2, but just disregarding this trap, right? Which will be non-deterministic, because if I get a 1, right, here, then that 1 is just going to, you know, fall off the edge of the world and be rejected. So that would count as an NFA, because if I just leave off this 1 and then leave off the trap, it won't be deterministic what will happen if I read a 1 from here. Okay, but rather than that, let's be a little bit more on the nose about it. Let's be a little bit more hard-headed about this, right? So if I read a 0, I go to a new state. If I read another 0, and I'm using an algorithm now, which is stupid, right? This is my dumb algorithm that's not clever. What should I do next? Well, I don't exactly want to loop 0, because then it would be possible to have as many 0s as I want, right? So I don't want to loop it. What do I want to do instead? But my choices can't, it can't be possible to have a path for a non-accepted string to be accepted. So if I had the string 0, 0, 0, that can't have any possible way of being accepted, right? So the ones, yeah, so now you get it, right? The ones that are accepted have to have a possible path, and the ones that are not accepted, there does not exist any possible path to acceptance, right? Does that make sense? That would be even worse, because then I could just have a single 0 which would be accepted, and that's against the rules. I need to have a double zero. So let me help. So the stupid thing to do is say, okay, well, I've got a loop on ones, and then I've got a 0, 0. Well, each time I read a 0, I just go to a new state, right? And then I have a 1 star, right? So again, my 1 star looks like this, right? Now what I could do is I could make this an accept state, okay? And that's totally viable. But look what's happening here. I have 001 quantity star, and I haven't dealt with this yet, right? I haven't looped back to the beginning. But what I'd really want to do is if I read a 001 star, well, that looks like this. I go 001 star, and I want to be able to, from here, go back to the beginning. That's what the start says. It's saying, hey, well, I've finished out one of these. I go back and I can do another one if I want to, right? So what I'm going to do here is introduce a new kind of arrow. It's called an epsilon arrow or an empty arrow. And what it means is without reading an input symbol, you can travel along this arrow non-deterministically. You don't have to follow this arrow, but you could if you want to. It's like a cheating arrow. That's exactly right. Which you can't use in an FSA, but since it's non-deterministic, you definitely can in the NFA, right? So let's do one more example, and then I'll give you the algorithm to convert from a regular expression into an NFA. But let's do one more example first. Okay, let's say I've got my regex here. 0 star, 1 star, 0. Okay. Let me show you what will not work. Right here, I'll just show it to you up here. Here's what will not work. Why won't this one work for this regex? Yeah, David, that's right. The definition of FSA is just there exists a path to get to an accepting state. Yep, that's exactly right. Yeah, this one allows 1010. So what regex does this FSA correspond to? Or I should say NFA. NFA. So what regular expression is this? Yep, 0 or 1 star, 0. See the correspondence? I got 0 or 1 star sitting here, and then a 0 gets me across to accept, right? And this one's different. Here the zeros have to come before the ones. So how am I going to arrange my NFA for this one? What kind of states am I going to need? Does anyone see how to ensure that the 0 stars all come before the 1 stars? Okay, the first state has a 0 loop, a 1 to the next state, which has a 1 loop, and a 0 to the accepting state. You're very close. Okay, so let me put in most of that, but not all of it. Okay, so I start off, I've got a 0 loop. I have an arrow to another state, which has a 1 loop, and an arrow with a 0 to my accepting state. Okay, now what you said was there has to be a 1 right here. And Lucas, you got it. Instead of a 1, we're not required to have a 1 anywhere, right? We don't have to have a 1 for this to work. So this can just be an epsilon transition, right? That's my cheater arrow, right? I can just magically move here and you see, excellent. And then I can just read that single zero by itself and be successful, right? Okay. So let's see if we can discuss the transformation of a regular expression into an NFA, right? So we're going to start out and we're going to do the sort of recursive definition of regular expressions, okay? So a regular expression could just be some alphabet symbol, okay? So if my regex looks like this, just 0, right? Then what's my NFA going to look like? It's just a single symbol. One state, no arrows. Not quite, because that would be 0 star. If it was one state, we'd have to loop it, right? But if we're reading one symbol, we will need to have one transition arrow. You see what it looks like? Okay, I think it's I'm asking it wrong. So let's say that we have let's not 0. Let's call it A, right? We just have some symbol. Our regular expression is just a single symbol. Well, my NFA is going to have a start state, an arrow on that symbol to an accept state. Yeah, start and then an arrow with 0 to accept, or since I changed it to an A, an arrow with A to accept, right? Does everyone see how this regular expression, which is a single symbol, has that corresponding NFA? Any questions? It doesn't matter how big the alphabet is either. If we had A, B, C, D as our alphabet, well, B, C, and D just die, right? There's just no arrows for them, so they're an automatic fail, right? What if I want to concatenate two different symbols together? So my regular expression looks like this. Let me do AB for this one. What's my NFA now? So the only string that I want to recognize is AB. How many states do I need? Let's start with that. 3 states. Okay, my first one will be an A arrow. Second one will be the B arrow. Okay, which one is going to be the accept state? The last one. Very nice. Okay, let me ask you this. Instead of having 2 symbols, what if I had 2 regular expression formulas? Okay, so I'm starting to get, so these are my base cases. I'm starting to now get into recursive cases of how to build these things, which I think is going to make sense for you. So let's say I have regex1, regex1 has the following NFA. Here's NFA 1. Let me do it this way. NFA 1, which looks like this. I have some start state. I have some, junk in the middle, blah, blah, blah. I don't know. And then some accept states over here. maybe like a reject state, who knows? Some other stuff going on. Here's NFA1. Here, I've got regx2, the second one, is giving me NFA2, NFA2, which looks like this. Here's NFA1, here's NFA2, looking like this. Again, I have some start state. You know, I go off to some accept state here and some reject state down here. Okay. If I want to make a regex for the concatenation of the regular expressions 1 and 2, so regex 1, 2, where they're concatenated, what's my machine going to look like for that? You see how we can concatenate the machines that correspond to the regular expressions? New starting state with epsilon arrows to old starting states. Close. You almost had it there, Lucas. So it does have to do with starting states and epsilon arrows, but you didn't have which ones go to which ones the right way, right? So if I have NFA1 here, and then I want to do NFA2 right afterwards, where are my epsilon arrows going to go from and where do they go to? Let's call this starting state 1 and starting state 2. Let's call these accepting states 1 and accepting state 2 down here. And what I'm trying to do, epsilon arrows from the first accepting states to the second starting state. Perfect. They're going to pop in like this. Here's an epsilon arrow here. Oops. And here's another epsilon arrow here. Right? So all that you do is you run through the first NFA that recognizes the first regular expression. Then you cheat and jump down to the second NFA, which does the second regular expression right after it. Right? So if you want to concatenate these regular expressions, you just do the first one first, then epsilon jump to the second one and do that. What do you guys think? Does that make sense? People have questions? What do you guys think? Looks good. Okay. So what if I do another example? What if I have my regular expression, regx1, is going to give me NFA1 over here. So here's my, you know, boo, 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 boo. There's an accept state, a reject and accept. And this is my NFA1. Well, what if I want to find the star of regx1? So I have some regular expression, and I want to find the star of it. How am I going to modify my NFA? It's going to be similar to the last one. Good. Epsilon arrows from the accepting states back to the start. Perfect. So we got one arrow going here, another arrow going here, and these are both epsilon arrows. Right? Because if it's a star, then I can do it through once and do it again, right? Or, ooh, but now what happens? What I missed one thing in my NFA. I go through it once, I'm accepted. Yeah, I have to deal with the idea that I can do it no times. So how should my NFA have been different? Even my original one was wrong. What's wrong with this? Yeah, the first state should have been accepting. The start state should have been accepting. Because anytime you have a star, if you have nothing there, you're automatically accepted. So no matter what, even on the first regular expression, oh, well, see, but no, but that one didn't have a star. So I guess when I put in these new epsilon arrows, right, I'll have to switch around my starting state as well to be accepting, right? Another thing that I could do is I could have these epsilon arrows transition to an accept state, which then epsilon transitions back to the start. I could do it that way as well. But I think just making the start into an accept state, that works fine, right? Okay, let's do one more example. Okay, so now let's say I have regx1 is given by NFA1, which looks like this. I have my start state, boo, boo, boo. There's some stuff in the middle. You go to accept, reject, reject. Regx2 gives me this NFA. And here's, let me just say, here's NFA1. Here's NFA2. Maybe I go to 2 accept states. Why not? Okay, there's NFA2. How is regx of 1 or 2 going to look? Oops. So this is my last symbol for regular expressions. I did concatenation, I did star, the last one's or. So as soon as I do this one, I'm done, right? So what do you guys think? How can I build a new NFA that will do 1 or 2? A new empty state, I'll say starting state, right? I mean a new starting state with 2 epsilon paths that go to the original NFAs. That's exactly right. So here's, just NFA1. And here's NFA2. Right? I can go this way or I can go this way. Either one's my choice. Right? What do you guys think? Questions? Okay, so let's try to convert a regular expression to an NFA using those 3 rules. I guess 4 rules, including the base case. Okay, so I'll give you a sample one to start. Let's say that I have this regx. Okay, let's say I have 0 or 1 star, oops, star, sorry, star, 0, 0, 1 star. Okay, so this one's going to be a little bit complicated, right? I'm going to start off on the left. I have, and inside the parentheses, so I'll start at the very beginning. I have 0 or 1, right? So what's that going to look like? Well, I have an or here, so I'm going to start off at my starting state. I'm going to epsilon transition to my first
NFA, which from the starting state reads a 0 and brings me to an accept state, right? Or I epsilon transition down to my second NFA, which is reading a 1 to get to my accept state. And I shouldn't have actually done an accept state on there because it won't be accepting at the end of the day, right? But you see what I did? I have my OR and then a 0 to accept, or I do a 1 and then a 0 to accept. And this whole thing can be starred, right? So I can do this as many times as I want, meaning I can epsilon transition back to the start. Now I've taken the star into account. Then I have a 0, right? Well, what's going on there? Well, now from here, if I decide I'm done with this first bit, I'll just pop right out here, reading a 0 into a new state, okay? From which I'm going to epsilon transition into my last little part, which is reading 0, 1 as many times as I want. So first I'm going to read the 0 and then the 1 as many times as I want, which means that I can epsilon transition back to the start here, which is in fact my accepting state. See what I did? See how I use the above rules of concatenation, star, and OR? People have questions? What do you guys think? How does this help us? Okay, that's a great question. We now have an algorithm, a stupid way that a computer can do to convert a regular expression into an NFA. What we're going to show next is that we can go from an NFA back into a regular expression. Okay. And that's going to show that NFAs and regular expressions are equivalent to each other, right? So that anytime I have a regular expression, I can show it in terms of an NFA that'll recognize that exact same language. Or if I have an NFA, I can transform to a regular expression that'll identify that exact same language, right? People good with that? Questions? Okay, let's try another one of these, right? Another one of these translations. And I'm going to have you guys work on this one. So what if I have this regex? Okay. It's almost like proving you can make all the logic with and or not. Yeah, it is similar to that. Yeah, so let's say I have 0 star, 1 0, 1 star, and that whole thing starred. Oh, you know what? Here, let's do it this way. I'll have 1 or 0. I'll put that in. I'm gonna have an or in there somewhere. Okay. So where am I going to begin? How do I start evaluating this expression? Or maybe I should say translating this expression. Okay, so let me help. So I start by reading a 0. So here's the very most basic thing I'm going to do. I got a start state. I'm reading a 0. And I'm going to another state. Okay, so I didn't mean to make the states different sizes. There's no real reason for that.
Okay. Now the 0 is being starred. So what does that mean? An epsilon arrow back to the start. Very good. Okay. Now I've taken care of 0 star. And this is my start state and my accept state, right? So where do I go from here? Now what happens? Well, it doesn't have to be, right? I could make an accept state here, or I could make this one the accept state. Really kind of, well, if I made this one the accept state, then I would have to read at least 1 0 to get there, right? Which I don't have to do. I don't have to read any zeros to get there. So the starting one should be the accepting one, right? Does that make sense? Okay, cool. So here's my accept state. Where am I going next? What's my next part of my regular expression I'm going to deal with? A 0 or 1. Okay, good. Or 1 or 0. Either way, I just put it out of order because I was being goofy. But 0, 1, 1, 0, it's a commutative, right? Okay, so how do I deal with that in terms of my states? So what's going to come out of this guy? Two epsilons, or go into a new state with 1 arrow into accept and a 0 arrow into accept. Yeah, so I think I can get away with just 1 epsilon. Let me go over here. Here's my epsilon, just to 1 state. And then from here, I can go into 2 new states, right? A 0 going up to here, and a 1 going down to here. Does that make sense? Yep, okay, cool. But if you read a 0, you don't have to read a 0 or 1 next. So you can't just accept 0. No, you can, because you're starting here. Here, maybe I should do this. Here's my start state, right? The start symbol got lost because I turned it into an arrow. Sorry, I was being a goofball. Here's my starting state. I can just immediately epsilon over to here and then do a single 0. Does that make sense, Amber? Does that answer your question? No, the start of 0 to epsilon and then accept. Okay, the start to 0 and to epsilon and then accept. Well, okay, so if I have, the regex says you can't have just a 0. No, you can. You can have a single 0 in here. That's possible, right? I could have nothing here, and then a single 0 here, and then nothing here exactly 1 time, right? Does that make sense? Yeah, okay, great, you got it. Okay, so I've got my starting state. I can do a 0 star. After my 0 star, I go into my 0 or 1, okay? And then I have, that goes to a 1 star, so what happens next? So these are both accept states. So where are these guys going to go? Let me help a little bit. I'm reading a 1 over here. Okay, so to read a 1, it looks like this, right? I have a start state, and I read a 1 over to a theoretical accept state, right? Okay, so how are these guys connected? How do I get from my 0 up here and my 1 down here over to my starting state? So what are my connections here? Go by one without, okay, yeah, I could put a one in here. No, I can't, because that would require there to be a one, and this is a 1 star. So I might be able to get there without seeing any ones at all, right? But you said without epsilon, so obviously what I do want here is some epsilon transitions, right? You see why you can't put the ones in there? Because then you're required to have it, right? Does that make sense, David? So the idea is that, so I think I see where you're going with that. So the idea is you want to sort of minimize your accepting states because you don't want them to be sort of like spread all over the place, right? Because that makes it a little bit harder to read. So we're going to see if we can end up with just one accepting state. You don't have to do it that way, but I think it's a little bit easier to understand, right? So here's sort of the old accepting states from the 1 or 0 machine. Those old accepting states go to the new start state for the 1 star machine, right? The 1 star machine is missing its star. So how do I incorporate the star into this little machine here? Epsilon back, right? Epsilon back 1. So I could do a 1, right? Or I could not do any ones at all. Oh, but you know what? Well, that's hard because, well, I guess now this is my starting state and my accepting state, right? And from my accepting state, the whole thing is starred. So my last step is that I can epsilon all the way back to the beginning. And that takes care of this star right here, is this guy. And this is my accept state. What do you guys think? Look okay? Let me pause there for a minute and see if you guys have questions. Okay, so here's what I have so far. I'm able to convert a regular expression into an NFA. Here's what I'm shooting for. Show you this. Some old notes I had here. Here's what I want. I want to be able to convert a regex into an NFA and back again. I want to go both directions. Here's a double-sided arrow, right? So I want to go regex to NFA, NFA back to regex. Okay. From there, NFA, I want to go back and forth to an FSA. And if I can go back and forth back there and back there, right, then an FSA and a regex are actually the same thing, which is the whole proof that I'm shooting for, right? I believe it's called Claney's theorem, right? So here's what I have so far. I can convert any regular expression into an NFA, and here's how I did it. Here's how to concatenate two regular expressions, x and y. I start off with my machine for x. I epsilon transition from the accept states of X to the starting state of Y. And that's how concatenation works. I just glue these two machines together, X and Y, with the epsilon transitions here. If I have a union, what I do is I make a start state, a brand new start state, epsilon transition to X, and epsilon transition over to the Y machine. Right? That's how to take care of union. Finally, for star, I take my accept states and epsilon back to my start, which actually should turn into an accept state as well. Right? Questions? Okay. So I have two more things to prove. Now, or should I do another example of this? Is this working for you guys? Does that make sense? Or should I do another example of that? Lucas, you're on track. How about other people? What do other people think? Anyone else want to see another example? Raphael, you want to see one more? Okay, let's do one more. So here's our regex. Okay, I've got a 0. Yeah, we're going to go from NFA to regex. Yeah, we're going to do that next. I'm just going to do one more example first. Yeah. So I got a 0, 1 star, 0 or 1, 1, and then this whole part is start. Okay, so first of all, let me just write down the different machines. So first of all, my first machine is a 0. So it looks like this. Okay, my next machine is a 1. So here's my 0 machine. Okay, here's my 1 star. My 1 star machine looks like this. I start off in an accept state. I'm going to do my accept states along the way. I'm going to do a dotted line in here, right? Reading a 1 goes to another state, and then epsilon's back to the start, which is accepting. Here's my 0 or 1 machine. Okay, I start off here and reading a 0. I go up to my accept state, a temporary accept state, or reading a 1, I go down to another temporary accept. And from either of those, my last machine is the 1 reader machine, which looks like this. Reading a 1, I accept. And I guess what I should do, I'll make this into a temporary accept as well. Okay, so how are these all going to be connected? Well, the 0 goes on an epsilon transition to the next machine. Here, my accept state goes on an epsilon transition to the next machine. Here, all of my accept states go on epsilon transitions to the next machine. And lastly, my accept state has a star, which brings me back to the 0 or 1. So this guy has an epsilon transition back to here. Okay. And this is my actual true accept state right here. Right? Because I can get there after just reading 0, 1 star, Or I can go through this whole second machine, the 0 or 1 followed by a 1 quantity star, which brings me right back to here. And that star here is what makes this the accept state and gives me that last epsilon transition. Good? That made more sense. Good. Yeah, absolutely. Okay. So one more time, here's what we're trying to show. We're trying to show that every regex can be expressed in terms of an FSA and vice versa. Okay. Now to show this, what we're going to do is two things, or two different ways. Okay. So from regex to FSA, here's how I'm going to do it. Regex to NFA, which we just did, and then from NFA to FSA. Okay, so I can sort of travel down this road. And separately, I can go directly from FSA back to regex. Okay, this one is done. I did this arrow. That's what I just showed you. I'm going to do this arrow next. And then lastly, I'll do this one to get back. And this actually we can do in a single step without using the NFAs along the way. Right? So this one is kind of like a two-step proof, whereas this will just take one. Okay, so let me work on this arrow, transforming an NFA into an FSA. Ugh, stupid paper. All right, so NFA to FSA. Okay, and for this, I'm actually going to do it by example, right? So here goes. Let me give you an NFA, and we're going to transform it. So here's my NFA. I start out, I'm going to start out in an accept state called 1. Reading a B, I'm going to come up to my state 2, which has an A on it. Either A or B is going to get me down to state 3. And A takes me back to 1, and an epsilon transition takes me down to 3. And there's my NFA. It has all the things of an NFA. There are epsilon transitions. Some states are missing arrows, right? 1 doesn't have an A coming out, so 1 is missing the A arrow. We have an epsilon transition. 2 has 2 different A arrows coming out. So I'm missing arrows, I have extra arrows, and I have epsilon arrows. So I have the 3 different things that make an NFA different than an FSA. So this is a very general example. It has all the 3 things that could go wrong. Is everybody with me on that? So if I'm able to do this one, I should be able to do anything. And this is not a proof. I'm just going to give you an example and show you how it works. But people happy so far? Okay. So here's my corresponding FSA. The states that I'm going to make here are going to be the power set of the states in my NFA. Okay. So here's what I mean by that. If we have the set 1, 2, 3, what's my power set going to be of that? You all remember power sets from chapter 6? The set of all subsets. So someone just give me some of it. Okay, so Nathan, you got it. Nice. Okay, so we have the empty set. 1, 2, 3, 1, 2, 1, 3, 2, 3, and 1, 2, 3. And these should all be in their own sets and have commas, but you get the idea. So here's what my FSA looks like. I have my empty set state, my 1 state, my 2 state, and my 1, 2 state. I have my 3 state, my 1, 3 state, my 2, 3 state, and finally my 1, 2, 3 state. Now, why am I doing this? Okay, let me talk about that for a second. In a non-deterministic system, your location is not determined. So if you are thinking about your location, which state are you in this machine, you could be in multiple states at once. It's not determined which state you have to be in a given transition. For example, in my start state, I can epsilon transition over to 3. So in my start state, I could be in state 1, or I could be in state 3, or maybe looking at it differently, I can be in state 1 and state 3 simultaneously. Or to put it in terms of quantum mechanics, I'm in a superposition of states 1 and 3 because of this epsilon transition, right? What do you guys think about that? Does that make you happy? Shorting your start cat state. Yeah, that's right. Stat cart shorting your state, all right? So what's my starting state in my FSA? Let me ask you that. Which of these 8 is going to be my start state? Not empty, not quite, no. 1, 3, perfect. Because my starting state actually here is 1, or I could have epsilon transitioned over to 3. So I'm in, and when I'm starting, I'm in states 1 and 3 simultaneously, which is depicted by this state here. This is where I could be in state 1 or state 3 or both at the same time, superposition, however you want to look at it, right? So here, I'm going to make my starting state 1, 3. I'll put a little starting state here, right? What are my accepting states going to be over on my FSA here? Not 0, nope. Anything with a 1, good. If I'm in state 1 over here, well, certainly that's accepting because state 1 is accepting over here. But what if I'm in simultaneously states 1 and 2? Well, that's still accepting because there's a possible route that left me in 1 rather than 2. If I'm in a superposition, I could be in either one of these, which means that there's some way to get to 1 from it. So 1, 2 is also an accept state. 1, 3 is also an accept state, which we can see right from the beginning, right? Because if I'm starting off in state 1, I'm simultaneously in states 1 and 3, which is accepting. And of course, this last one, 1, 2, 3, is accepting as well. Let me pause there for a minute. People happy with the idea of superposition, being in multiple states at the same time? Or you can think of it as being in one or the other. Any questions? Okay, so let's see if we can fill in the rest of the arrows, right? And let's start at the starting state, 1, 3, okay? So if I'm in the starting state 1, 3, which means I could be in 1 or 3. Now this is an FSA, so I have to put an A arrow and a B arrow because my input alphabet, you know, my input alphabet here, sigma, is AB, right? So I need to have an A arrow and a B arrow coming out of each one of these states. So I have 16 arrows total. Okay, now let's start with the A arrow on 1, 3. So I'm in states 1 or 3, reading an A. Where can I get to from that? So let's start with 1. If I'm in state 1, reading an A, where can I get to? It'll be a loop. Okay, why is that, David? So if I'm in 1, reading an A, how do I get to either 1 or 3? Epsilon, right? So I can go epsilon. So starting from 1, I can do epsilon and then A and get back to 1. Or I could do epsilon A epsilon and get to 3. Well, what if I'm at 3? Well, from 3 reading an A, I can get to 1. Or from 3 reading an A, I can get back to 3, A and then epsilon, right? So you can think of it sort of as the set of reachable states reading an A from this combination of 1 and 3, right? You see the set of available states reading an A is either 1 or 3, because of course I can get to 1 on the A, or I can epsilon transition back to the other one at any time. So 1, 3 is going to be an arrow with an A. Okay. How about a B? If I'm in 1 or 3, what states can I get to reading a B? So I'm in states 1 or 3, reading a B, where can I get? Just 2. Perfect, right? Because I can't get anywhere from 3 reading a B, there's no B arrow coming out. The only place I can get to on a B is from the 1 state, and the only place I can get to it from there is 2. So the B arrow on the 1, 3 combination goes to 2. Let's try another one. Okay, let's say I'm only in the 1 state. Okay, from the 1 state, reading an A, where can I get to? Only back to 1. The only thing I can do is epsilon down to 3, and then read that A to get back to 1. So 1 on an A goes to itself. Okay, what about 1 on a B? Where can I get to from that? So from 1, reading a B, where can I go? Not 0. Definitely to 2, right? I can get to 2. Or if I take the epsilon first and then try to read a B, well, that doesn't do anything for me. That's okay, no problem. Yep. So 1 reading a B gets me to state 2. Okay. Let's try another one. Let's try state 3. I'll just sort of do the left half and then I sort of started in the middle. So let's do the left half. So starting in state 3, reading an A, where can I get to? So did you say 1 as a response to this one, Nathan? Not 1 or 2, Latifat. So from 3, reading an A, I can get to 1, but I can't get to 2 because I would need an A and then a B to get up to 2. So I can get to 1 on an A, but what else can I get to? Also 3, back by that epsilon arrow, right? So on 3, reading an A, I can get to 1 or 3. How about on 3, reading a B? Where can I get to? Nothing, okay? So now we can finally use this guy, okay? Because 3, there's no way out on a B, right? I'm trapped. So if I read a B, that means I'm dead, right? Fell off the edge of the world. So my B goes up here to my trap state. And where do A and B go on my trap state? Yeah, trap, loop, right? So in my trap state, I'll have A and B, and the empty set just means the trap state, right? Means you're not in any state at all. This is just which states are you in? I'm in states 1 and 3 simultaneously, or I'm just in state 2, or I'm in all of the states simultaneously. This means I'm not in any state, which means I'm dead, right? If I'm not in any state and I read more stuff, well, I'm still dead. And I still fell off the edge of the world, okay? So at this point, I've done the empty set, 3, 1, 3, and 1. Let's do the remaining parts, okay? So let's do state 2, okay? If I'm in state 2, reading an A, where can I get? So I'm in state 2, reading an A, good. I could get to 2 on the loop, or I could get to 3 on this arrow. So on state 2, reading an A gets me to 2, 3. Right? How about on state 2 reading a B? Where can I get to from there? So I'm in state 2, reading a B. Where can I get? Not 1, 3, almost. You can get to 3 on the B, but look, this epsilon arrow is going the other direction. So I can't take an epsilon from 3 up to 1 since this arrow is pointing the wrong direction. Does that make sense, Ladafat? Yes, okay, cool. So on 2, reading a B, I can only get to state 3. Right? Okay, let's do 2, 3 next. So from 2 or 3, reading an A, where can I get to? Okay, I can definitely get to 1 because reading an A from 2 or 3, well, let me start at 3, read an A, and I'll get to 1. Right? And of course, if I can do that, I can epsilon back to 3, right? So from 3 reading an A, I can bounce there and back. So I have 1 and 3. Or from 2 reading an A, I can loop or go to 3. So from 2 or 3 reading an A, I can get to all 3 states. Yeah. How about 2, 3 reading a B? Where can I get to from there? Yeah, just 3. Or empty, but see, we can only have the arrow going to one destination since this is deterministic, right? So it could have been empty if we were doing an NFA, but since we're doing an FSA, we only have one option. Right? Right. Cool. Okay, we're almost there. 1 or 2, reading an A, where can I get? Two, 3. Okay. So from 2 reading an A, I can get to 2, right? 2 reading an A gets me to 2, or 2 reading an A this way gets me to 3, right? So 2 reading an A gets me 2 or 3. how about 1 reading an A? Because this is 1, 2, right? So I can also start at 1. Where else can I get to reading an A from 1? I can also get back to 1 because I can epsilon and then read the A. So actually 1, 2 reading an A gets me all 3 states, right? How about 1, 2 reading a B? Okay, definitely to 2, because 1 reading a B gets me to 2. But then how about 2 reading a B? Where does that get me? 3. So this one gets me the 2. This one gets me the 3. So on a B, I can get to 2, 3. Right? Almost done. 1, 2, 3. So on all 3 states, reading an A, what can I get to? 1, 2, 3. Very good. Okay, how about 1, 2, 3 reading a B? Where can I get to? Two, 3. Very nice. All right. And so you can see what I've done here, right? I have an NFA. I make an FSA with the states equal to the power set of my original NFA. My starting state is is determined by any of the states that are simultaneous with my start state here. And my accept states are any states that have the accept state in it, which are these 4. Then what I do for the arrows is go through and just list out which states are available. And now I do have a tried and true FSA. It has an A and a B coming out of each arrow, has start state and accept states, a totally acceptable FSA. And I can use this method to build an FSA out of any NFA that I want. You guys believe that? I mean, it would be really tedious, but you believe it would work? Yeah, you do. Anyone not believe it would work? Have an argument as to why it could fail? Okay, cool. So in that case, let me do my last little proof here, which is FSA to regular expression. Okay, so far I've gone regx to NFA to FSA, and I'm going the other direction, FSA back to regx. And again, I'm going to do this just by example. Here's my last little example that I'm going to do. Okay. So here's the FSA I'm going to start with. My start state here at 1. I've got 2 and 3, which are accept states. 1 goes on an A back and forth. 2 has a B loop. A goes this way here. And we have a B loop here, back and forth. Okay. So there's a perfectly good FSA. The first thing that I'm going to do is I'm going to make a new start state over here with an epsilon transition in. Oops, not a 3, epsilon. There we go. There's my epsilon transition in. Looks kind of gross, sorry. And then from my accept states, I'm going to epsilon transition out to one single accept state over here, which doesn't really change anything, right? Is everyone good so far? And then these are not going to be accept states anymore. I'm just going to have them epsilon transition over to a separate accepting state. And I'll call these S and A for start and accept. Okay. Now what I'm going to do is I'm going to eliminate states one at a time. Okay. So my first step is going to be to eliminate state one. Well, let's see how I can do that. Okay. As I eliminate states, these transitions are going to change, and I'm going to use regular expressions to talk about the transitions here. And that's what I think it was David. Someone was asking earlier, can we do multiple steps at once on an arrow? Here's where we're going to break that rule. The very last rule we're going to break here, right? So what am I going to do? Well, in my new machine, I'm going to eliminate state one. So all I'm going to have is my start state, S, my states 2 and 3, which are now not accept states anymore. They're just regular old states. And my accepting state over here. And state 1 is going to be eliminated. Well, let's see how to do that. Well, from my starting state, how do I get to state 2? Well, if I go through state 1 and then take an A, that'll take me to state 2, right? So what I'm going to say is, okay, well, my starting state on an A, I'm going to go over to state 2, right? How about my starting state to state 3? How can I get there? Through state 1. How do I get through? Yeah, on a B, right? I go epsilon to here and then B along here to get from start to 3 through the state 1. Okay. How can I get from state 2 to itself through state 1? So I'm in state 2. I want to get from 2 to itself using state 1. Not exactly, not AB. A is going to take me here, and what do I need to get back, right? I'm trying to do the regex for the loop on 2. Yep, it would be AA, right? I'm going to go A to get to 1 and an A to get back. So AA brings me from 2 to itself. How else can I get from 2 to itself? B, right? So I can go AA, or I can take the B loop. AA or B. See, I'm taking these arrows and I'm replacing them with regular expressions as I delete states. And the more states I delete, the more complex these regular expressions become, until eventually I just have the start and the accept and one big old regular expression arrow in between them. That's where we're headed, okay? Let's see if we can finish it off. From state 3, how do I get from state 3 to itself using A? Pardon me, using state 1. How do I get from 3 to itself using state 1? BB. Very good. I go B up and then B back. So I need a new loop on state 3, the BB loop. Okay. Similar question. How do I get from state 2 to state 3 going through state 1? So 2 to 3 through state 1. How does that look? State 2 to state 3 through state 1. AB, very good, right? I take the A arrow here, and then the B arrow here, okay? How about from state 2 to 3, or pardon me, from state 3 to 2 using state 1? So 3 to 2 using state 1. BA. Yeah, great, Natasha. That's right. And how else can I get from state 3 to state 2? I can do BA, right? What's the other way to get from 3 to 2? Instead of going through 1, I could just go directly there, which is or A, right? So from 3 to 2, I could go through 1, B, A, or I could just go directly on the A. So B, A, or A, right? Do we need some stars? Not yet. We're getting there, right? So can I get from 2 to the accept state through state 1? Is that possible? Can I go from 2 through 1 and then immediately to the accept state? In other words, in deleting state number 1, have I eliminated any routes from 2 to the accept state? No, right? The only way from 2 to the accept state is an epsilon arrow. Boom. Same story for state number 3. I can't go through state 1 and then jump to accept, right? The only way to get there from 3 to accept is on that epsilon arrow. So in deleting state 1, I haven't generated any new ways to get to my accept state, right? Because there were no ways to get there through 1 in the first place. Let's do another one. Okay, we'll do one more, and then I'll let you guys go here. So if you need to leave now, that's fine. I'm going to go a little bit over. Okay, so now what I'd like to do is delete state number 2. Okay, so here's what I'm going to have. I'm going to have my start state, my accept state, and state number 3 down here. Okay, so we got to do all the options. So how can I get from my start state to my accept state through state 2, which I've now deleted? So here's start to accept, right? And through state 2, what does that look like? Well, I'm going to get an A followed by as many repetitions of A, or B as I want. Right? The A first, then a bunch of loops of these, and then an epsilon. Okay. How about from my start to state 3? Well, for that one, I could have a B, right? That's the fast way. Or I could go A, or B, star, followed by AB. So I could do B to get directly there, or I could go through state 2. Going through state 2 gives me an A, or B star, as many times as I want, and then an AB to finally get me there. How about from 3 to itself? Well, can I get there the regular way? Yes, BB. Or I could go through state 2, which I've now deleted, which would look like this. I would have BA or A, followed by AA or B star, followed by AB to get back. Right? Lastly, to get from 3 to my accept state, well, there's no way to get there originally, right? But to get there through 2, what would it look like? Well, through 2, first of all, I'd have to do BA or A, followed by AA or B star. What do you guys think? They add up fast, don't they? Yeah, so I'll leave it as an exercise for you guys to delete state 3. And if you do that, you're just going to have one arrow, right? You'll have this guy or this one followed by this one followed by this one, concatenated, right? And that is the regular expression that corresponds to this FSA that we started with. What do you guys think? Questions? All right. So does anyone have any other questions before we go? Your practice final is going to be due, right before your final exam. I believe that's on a Saturday. So you should definitely look at that and post your responses in the discussion forum as usual. Your final is going to start on Saturday, and it'll go Saturday, 11:59 a.m. So Saturday night up until Tuesday night, 11:59 p.m. Sorry. So you have 3 days to work on it. In that 3 days, your window of time will be 3 hours to actually complete the exam. And if you want to take it on Monday from 1 to 4, I'll be hanging out here in the chat on Zoom to answer questions if y'all have any and you want to take it at that time. But if not, you take it whenever you want, anytime before Tuesday night. Any other questions for me before we go? What'd you guys think? Is this fun? What did you guys think about this last week? Yeah, my favorite too. Yeah, so as you move on and you take a upper level, 300 level theory of computation, all of it centers on regular expressions, finite automata, non-deterministic automata, and finally Turing machines. Turing machines are a more complicated version of these, which is something that you get to in your next theory of computation course. So that's why I wanted to focus a lot of time on this material, because that's going to be sort of the focus of the next class after this one in terms of your mathematical and theory courses. So yeah. Cool. Okay, anything else before we go? Does that all sound good? Yeah, you're very welcome. Okay, well, I will see you all on Monday, or some of you on Monday. If I don't see you, yep, good luck on the final, and I'll talk to you soon. Have a good one, guys.